A pristine commercial epoxy floor looks practically indestructible. It presents as a massive, seamless expanse of hardened resin reflecting the overhead lights. But under the wrong conditions, that perfect surface can easily scratch, dull, and peel away in jagged sheets. Facility managers choose epoxy because of its specific structural advantages. It forms a virtually non-porous barrier that repels most industrial chemicals. Because it cures as a single continuous layer, there are no grout lines or seams for dirt and bacteria to hide in. Yet the coating has hidden vulnerabilities. The top layer easily takes on permanent scratches from abrasive friction. It reacts to prolonged ultraviolet light by turning a dull, sickly yellow. And if moisture migrates up through the concrete slab underneath, the entire epoxy layer will lose its bond and detach from the floor. The fastest way to trigger these failures is not heavy machinery or excessive foot traffic. It is improper cleaning. Dragging heavy grit across the floor or applying the wrong chemical agents actively degrades the resin, accelerating wear and tear. Preserving this surface means understanding that you are handling a delicate coating. Keeping it intact requires a precise, chemistry-based protocol rather than aggressive mechanical scrubbing. Before a single drop of water touches the floor, a professional maintenance run starts with a visual inspection and an adhesion check based on the AS 2150.1 testing standard. The test requires scoring a grid into a small section of the epoxy. Once cut, apply high-strength tape firmly over the squares. When you pull the tape back, look for intact squares. If chunks of the coating break away, the base bond is failing. A failed test indicates the substrate bond is already compromised. Running a heavy, wet floor scrubber over this area would allow the machine's suction and mechanical force to rip up huge sections of the coating, causing thousands of dollars in delamination damage. Relying on this objective test provides mathematical proof that the floor's bond is strong enough to withstand industrial equipment before the wet cleaning process actually begins. With the bond verified, the actual cleaning begins with the dry prep phase. Every square inch of the floor must be cleared using a commercial HEPA-filtered vacuum. Skipping this step and going straight to mopping leaves behind microscopic particles of sand, dirt, and metal shavings. Mixed with water under a mop or scrubber pad, that grit acts like liquid sandpaper, destroying the glossy finish. Once the loose debris is gone, the wet phase relies on exact chemistry. You dilute a pH-neutral cleaner to the manufacturer's precise specifications and apply it strictly with microfiber mops. Traditional cotton string mops are out. They leave behind tiny lint fibers that dry onto the surface and dull the shine. You must also avoid acidic or highly alkaline chemicals, which slowly eat away the resin structure. For large, heavily soiled commercial spaces, a walk-behind auto scrubber does the heavy lifting. The requirement here is equipping the machine with soft polyester brushes. They agitate the surface just enough to break up grease without scratching the epoxy. You must never attach abrasive scouring pads to these machines. They inflict thousands of microscopic scratches into the top coat, leaving a permanent cloudy haze. The entire strategy for cleaning epoxy relies on chemically lifting dirt away, completely avoiding any abrasive force that would compromise the microscopic smoothness of the top layer. Environmental damage requires specific triage. In workshops, hot vehicle tires resting on the floor transfer thermal energy into the resin, softening it. When the vehicle moves, the tires physically tear the epoxy right off the concrete. This is solved by applying high-build, thermal-resistant top coats. Chemical staining from hydraulic fluids or harsh solvents requires speed. Facilities need a rapid spill response protocol to wipe up these substances within minutes, neutralizing the area with pH-neutral solutions before the stain sets into the resin. If the floor sits under skylights or large windows, standard epoxy will turn yellow from ultraviolet radiation. The fix is preventative, applying a UV-stable polyurethane topcoat to block the radiation and maintain the original color. This diagram shows the logic tree for deciding when to repair versus when to replace. When assessing the floor, use the 30% rule. If isolated chips and scratches cover less than 30% of the surface, sand the edges and spot patch the damage. If widespread delamination or yellowing exceeds 30%, you need a full recoat. Diagnosing the exact root cause of the damage allows you to target the repairs. keeping isolated wear and tear from spreading and compromising the rest of the floor system. Protecting the floor long-term requires a 3-tiered maintenance schedule. Run a HEPA vacuum daily to remove abrasive grit. Mop with a pH-neutral solution and microfiber weekly to lift light soils, and bring in the auto scrubber for a deep clean every quarter. For a standard 300 square meter warehouse, bringing in professionals for that quarterly inspection, HEPA vacuuming, and machine scrubbing requires an investment of around $1,500. This bar chart compares that routine cleaning fee against replacement costs. Pouring a fresh epoxy application costs $30 to $60 per square meter. Letting a floor degrade until it needs a total replacement is an incredibly expensive failure. Sticking to the routine maintenance schedule keeps the facility compliant with safety standards, ensures slip resistance, and maintains a clean, professional appearance. Executing this protocol elevates epoxy maintenance from a simple janitorial chore into a highly profitable capital protection strategy. By actively preserving the integrity of the coating, you directly protect the financial resources of the business.